let's kick things off. I'm Hannah Daniels. I'm here today with Evan Bress, and we are going to be talking all about exploring the outdoors and specifically creating field science experiences. This podcast is brought to y'all by MimioSTEM and our MimioSTEM team here. So within the MimioSTEM lineup, we have loads of different STEM and STEAM resources, different products such as our MySTEMKits curriculum, our two different sort of lab disc or Explorus science labs. So these ones are going to get featured a fair bit today. And of course, our 3D printers, which we talked a lot about in last month's Learning Lab. So at any point, if you all have questions for us in the chat or anything like that, we would love to have you all who are here live be part of the conversation. So as we kick things off, I just would love to get started by, Evan, if you wouldn't mind introducing yourself a little bit and talking about your background in field science.
Absolutely. I have a feeling that some folks on the call might have seen me in previous podcasts or events from MimioSTEM. So what I do nowadays is I work with Boxlight and I work with MimioSTEM as a training specialist to investigate and help teachers understand how to use both the MimioSTEM products and a whole range of other things from Boxlight. But actually, before Boxlight, I was a field biologist. So I'm dressed up in my old garb here with the background from my old field sites.
And
But
I'm
in
just dressed to
addition,
match,
yes, of course, your hat is even more exotic. I just got mine at REI, so your hat wins today. I think it's from New Zealand. Is that right?
Oh, wait, I lied. It was Australia, but same trip.
Close enough. Why split hairs there? But in addition to being a field biologist, I was actually a biology teacher. So I worked at Arizona State University with their undergraduate program, first as a TA through my graduate program, and then later on as an instructor, helping those freshmen primarily transition from more of that high school biology mindset into introductory biology as freshmen. And that was both in person and online. I transitioned from the in-person labs into online just around the same time as COVID. So it was kind of fortuitous timing there. But stretching back about a decade now, I led a lot of labs in the local Tempe, Arizona area. So I'll show you a few things from what I was doing more broadly in Arizona, actually for my career. But then also talk about what I would do with those students. Now, obviously, that was above the K-12 level, but I mean, just above. We're at grade 13 here. Most of those kids are really, especially in the early stages of college, basically still high school students. So a
Yeah.
lot of the things that I was doing are certainly at the level of a high school biology class, and maybe even pushing down into middle school. That's not to say that there are no field experiences that you can do with younger kids. And in fact, Hannah, I know you have a ton of lessons on that topic that we'll talk about today too. But that's where I'm coming from. That's what I did prior to what you might have seen me doing already here, which is working with Hannah and the rest of the great MimioSTEM team.
Awesome. Well, before we jump into all of those experiments, which I cannot wait to hear about, because, honestly, I've wanted to know for a while a little bit more about what you did out in the field. If you could help for those of us who are not native scientists or professional scientists, how would you sort of define or describe field science compared to some of the, classroom lab experiments that we did back in school?
Of course. So the primary difference is, of course, in most cases with field work, you're outside. I mean, I guess you could be in a cave or something, but mostly you are outdoors. That's what sets it apart.
Side,
Yeah,
sort of.
it still counts, I think. But it's getting away from that lab bench. And I don't want to put down lab science. That is core to our understanding of the world. And I did a ton of lab science myself, but it feels different and it is substantially different, especially for students to get outside. They don't always have that opportunity. It might be a little bit more complex in many ways, but it has a lot of rewards to it. Just starting to understand the natural world. So for me, field work is any type of experiment or observation where you are engaging with the natural world. And it doesn't have to be somewhere exotic. Hannah and I both recently were lucky enough to have the experience to travel to Australia, which is not something either of us had ever done before. And so we're going to probably share a couple things from that because it was super fun. But you do not have to go
But I
anywhere
mean,
exotic.
that's the point. Like, it's just breaking out of the norm.
Yeah. I
Like,
mean, I still remember even back in my high school days, like the one day that we got to go outside for science class was
mhm.
something that I still remember because it was different. And at least for me, that really spoke to my personality, my likes, my dislikes. I like being outside, digging around more than I like lab science. That's not the case for every student, obviously, and it shouldn't be. But it is a cohort of students that are going to respond differently and positively to that experience.
Oh, fully agreed. I mean, so in high school, I still hated science. I hated science most of my school career, which is hard to tell now because I love it. But
Yeah,
I remember in high school being given the option of chemistry or geology. And I lived in Colorado again at that point. So I'm like, you know what? Let's do geology because that class is get outside, go hike around, and look at cool rocks. And that sounded way more interesting to me
yeah.
than a chemistry class did.
Little
And
did you know
so
that geology is just fun chemistry. You still have to do chemistry.
we didn't have to memorize any elements of the periodic table. I think that was a big part of it too, was it was less memorization, more hands-on.
Yeah. Yeah, and it is just a different learning style, and some people are really drawn to that. It gives you, as an educator, the ability to reach different parts of your class in different ways. Because obviously, you're not going to go outside every day. Most of us are not lucky enough to work at one of those schools that has like an outdoor classroom, although maybe some of us are. Um,
And unlike some of our folks from Florida, there are certain times of year where going outside, say in Colorado, is a bit of a commitment because you're probably going to be dealing with, frigid temperatures and snow. Not that Florida doesn't reach its
I
own
would
time of year when
venture
you don't go
to say
outside.
that Florida has, maybe opposite times of the year, but they have plenty of problems with that as well. We're not trying to get anybody heat stroke here.
I also lived in Florida, yeah.
You
So
did. Yeah. Yeah. You're almost a Florida native just as much as Coloradan these days. So, but yeah, I think really the approach to take here is a balance, right? There are some things that you can only do with field work, and there are some things you can only do indoors. You can teach different concepts, you can teach overlapping concepts, but just see what results from trying to get outside a little bit more.
All right.
And like I was saying, that could just be the school backyard. Maybe
Mhm.
you have a athletic field. Maybe you have a garden in front of the school, or even just some planters. They all count because you're going to find wildlife or plants, even if it's just cultivated plants. You're going to see something different out there than you do at the lab bench.
100%. I know so many teachers who do, schoolyard lab experiments who I've heard about. And, certainly when I've gone out and done professional development, there's so many experiments we can do just right on the school's campus. So,
Mhm.
okay, this is awesome, but I cannot wait to hear more about your field experience. So, what are some of your favorite things you've gotten to do, both as a professional and then, of course, with students as well?
Sure. Well, I'll start with what I was doing in the classroom, and then I'll talk a little bit about what I did more for the research side of things, because still did involve a lot of students throughout my career at Arizona State. I made sure to
Makes
always
sense.
bring in undergraduates whenever I could. Not only did I need the labor, because I can't carry everything, and you'll see dragging big nets through the mud, it doesn't work very well by yourself, but it's an invaluable experience for those kids too. But for the class, I'm thinking back all the way to introductory biology, which was mostly held in the basement with the blacktop lab benches that most people are familiar with. We did experiments dissecting, we did experiments looking at nervous systems and conductivity, we did physiology experiments where we tested our heart rate and all that stuff. But one day, my favorite day, and maybe some of the kids' favorite days too, was going out to a nearby mountain. Tempe is smack dab in the middle of Phoenix, the metro area. But there is a wild patch very close to the Arizona State campus. It's called A Mountain because they drew a big A on it. You may have seen that in a lot of mountain towns. They love to do that.
It sure is true. I've lived in multiple towns with letters on mountains.
Yep, it's kind of a must-have out west, which I think that was the first time I'd seen it moving out to Arizona. But in any case, very common. Then, for Arizona State, it's like their school logo and all. But the rest of A Mountain is a hiking trail and just desert scrub. So you could bring the students for like a 10-minute walk, and then they would be out in what is essentially desert. And so we
That's
would bring
really
out,
convenient.
it is very convenient, yes. We would bring out quadrats. So I don't know if anybody's familiar with the term quadrat, but it's basically just a few meter sticks that are taped together. It's nothing fancy. It is a meter by meter square. You can even draw grid lines across it with string to further delineate your quadrat. But essentially, you would just put that down and quantify what is in that meter by meter square. So it is a really simple way to measure biological concepts and ecological concepts. So we would measure species diversity. How many species are in? Yes, Hannah, that's
I'm leaving a
correct in
little
the
note in
chat.
the chat.
Yeah, quadrant is probably a more common term, definitely a more common term, but
My
I
phone
promise I'm not
autocorrects
missing
it
an
every
N.
time.
Yeah. So a quadrat is it's just a square on the ground. Nothing too difficult to comprehend. But we would
Or under the
look
water.
at
I've seen underwater biology use quadrats as well, and like
yeah,
archaeology too.
absolutely. They're in use all over. It's just a standardized way of quantifying what you're looking at. You don't want to say like, oh, well, there was a beetle somewhere down there. I looked down and there it was. But you would much rather say, here was my meter square study area, and I found four beetles in this area, which is a much different and more precise way of talking about it. So we
Well, and
would
I've seen them
study like,
subdivided a load too.
yeah,
Doing lots of subdividers so it can be section A1 of
mhm,
quadrat
yep,
12.
absolutely. Depends on how big that study area is going to be. You
Mhm.
could subdivide your meter square, or you can go really big. If you're on an archaeological dig, you might have, several square 100 meters if you're looking at an ancient city or something like that. Um, but we would study, like, say, species abundance. How many of a species is in this study area? We could also look at species diversity. So, how many different types of species are in this area? If you find seven plants, but they're all the same species, that's different than finding seven different kinds of plants. We could look at species evenness. So are they clustered together? Are they dispersed relatively equivalent across the landscape? What might they want if they're clustered? Are they at a particular resource they like or shade or something like that? So there's a lot you can glean just from that. And this was a pretty simple lab. It was designed to be done in an average lab period. So it was just a couple hours long. We'd hike out, we'd hike back. I would always lose a few kids on the way back because we had to pass through like the restaurant area of campus and they would just peel off. But hopefully you don't have that problem with school age kids as much. Um, and
Presumably, kids wandering off would be a little bit more frowned upon at the K-12 level than it is at the, collegiate level.
a little bit more, yes. So keep track of all the kids, but you get back, you can do some very simple calculations to understand things like diversity and species evenness a little bit more. But at the end of the day, that might have been the only time that semester that those people had the chance to go out and hike. Maybe not, but I know there are plenty of students who do not have that opportunity every day, or maybe they do and they just don't take advantage of it. Maybe they'd prefer to stay inside and they haven't gotten that opportunity as often. So it's a really great way to start stimulating some of those extra neurons that they're not normally exposed to, trying to get them outside.
Well,
Now,
and I think
oh, go ahead.
getting students outside is also like just side benefit really good for SEL because if I think about it, I grew up a lot in Colorado, but I didn't like hiking because I was just surrounded by nature. It's a tragedy, I'm sure it is. But then I went to college in Los Angeles and I was just staring at a computer all the time and not getting out. And then I felt like drawn into nature because LA is such an urban landscape that it was there I learned to love hiking because I needed the escape. I needed the breakout from all of that. So I know a lot of students the same way. They're stuck in labs, they're stuck staring at screens, reading books, all of that. We've got a comment in the chat here. Yes, mental health benefits for students and teachers both. So yeah, I think that's such a huge part of it too that makes field science so important. Not to mention, of course, the science. And I am
Right.
loving this. Oh my goodness, tiny frogs and terrifying spiders. Sorry if you're spider averse. We'll add a warning on
Yeah.
the recording screen that this is coming.
Yes. Sorry to any arachnophobes out there. I promise it was not a dangerous spider and it only stayed on my hand for a few seconds. But yeah, so this is more of what I was doing as a scientist. So not only, of course, is it just nice to be outside at least many times of the year, but there are some real insights that you can gain that you can't get indoors. So this is an example of the research that I was doing as a biologist. I was studying amphibian biology and specifically communicable diseases. So if we think back to COVID times, everybody was very concerned with things like how easy it is to transmit this disease. What proportion of the population actually gets sick or even worse dies of this disease? Um, we learned epidemiological concepts like you know what is the herd immunity level that you need to have in order to keep everybody safe from this disease. So it was like a primer on epidemiology for everyone who hadn't gone to grad school for it. For me, it was really funny because I had already seen all those concepts, but only in frogs, and obviously there's a lot more issues when it comes to human epidemiology that are not an issue with frogs.
And it
Uh,
still applies. Like a
it
lot of
does.
the bases are still there.
Yep, same concepts. So this was the microorganism. I say I was studying amphibians, but really I was studying this fungus because this is sort of the key that we were looking at. It's a worldwide communicable disease of amphibians that has actually driven several species to extinction. So it's quite serious, at least in some species.
Oh
It
wow.
happens to be some of the really nice species, unfortunately. Things like bullfrogs that are big and loud are almost immune to it, and things like tiny golden frogs in Panama that are like just gorgeous to look at are extremely susceptible, and many of them did not survive or are only in zoos now. But in the mountains of Arizona, try not to think of deserts. If you can see the background here, it's actually
Yeah.
much more of a woodland and pasture land for grazing cattle. So it is much wetter, but still arid compared to a temperate forest. And there are ponds, both natural and man-made cattle tanks dotting that landscape full of amphibians. So we've got frogs, we've got salamanders, and we have this chytrid fungus, which is infecting all of them. So I would go from pond to pond throughout the year. I did not pull a large net through the water in the middle of winter because it was iced over, but I would take water samples to try
Oh,
to
okay.
find any floating fungus. But I would monitor the level of detectable microorganisms in that environment. And then if I caught any animals, I would test them for infection. So I was doing a population level survey of the prevalence of this particular disease in this environment. So you can see me here many years ago. I think this was maybe like 2014. So quite a bit back before my current hat, unfortunately. This was a tarantula that we found just next to the pond. But what I was actually looking for were these little guys. These are chorus frogs. They have them here in Colorado too. They actually stretch all the way up into Canada. So wherever there's high elevations, you can find these chorus frogs. At lower and wetter elevations, you will also find spring peepers, which are a closely related species of very similar little frog. We would find them by seining. So this is a long net. It's connected through the middle here, and my lab mate and my student here are pulling it through the pond. We would also find salamanders that hide under the water that you would never know were even there. They'd come up in the net. And so then we could
Huh.
test them. This is just a really cute little guy that I found. This is another species of frog that wasn't around most of the year. This is a brand new
Great.
Arizona tree frog, which is just a really brilliant green little species that I like a lot. And so I took that picture when I found him. But that is what I was up to. So I would go up, I would say rain or shine, but obviously I tried to pick days where it wasn't severe weather. But at least once a month, 12 months a year, visit the same sites and take as many samples as I could to determine if the infections were holding steady, if there were more examples of infections in certain months. Usually, you would tend to see it spike in colder months because the fungus doesn't like the heat. And then if we would notice, this year we found no frogs, and the ones that we did find were infected, that would be a bad sign. But luckily, we found that the populations were by and large stable. They were able to reproduce faster than the fungus was hurting them. So they were doing okay. It's one of the very few things that climate change might actually help in this part of the world because the fungus doesn't like hot. So
And yet it's in Arizona. Yeah, all right.
it is, yes. Yes, it hides in the cold pockets of that environment, deep in the
That
mud,
makes sense.
etc. The frogs don't like to bake themselves either. They will bask in the sun, but they are adapted to mountain life. They're not meant to be warm all year round. All
Very
right.
cool. Well, as people can see, we will be sharing some of our favorite technology apps later
Yes,
as
my
Evan
finger
scroll that along.
hit that button on my way to stop sharing the screen. But we did want to chat a little bit about some tools that you can use as educators. I don't think many of you are going to sign up to have your primary school kids drag a big net through the mud. I would not recommend it. They will get stuck. I got stuck many times. But there are other things you can do. And I don't mean to focus this exclusively on biology. It's just sort of what Hannah and I know best when it comes to going outside and looking for fun animals and plants. But just a reminder that this all applies. As I said, geology is just applied chemistry in many cases. This can be very much chemistry based as well. A lot of physics concepts are learned when you're in the lab. But there's plenty of like physics and astronomy and light that you can all investigate outside as well.
Yeah, I think it's important to note that we are going to talk a lot about biology, life science, earth science, that type of things, just because it's where our interest lies. But if you think about how, like, even if we talk about plants growing and such, there is physics tie-in. Anytime you're talking about waves, light reflection, all of that sort of stuff, there's so many good ways to tie these back to whether they are physical science standards or, I mean, we have so many lesson plans out there that are talking about, even like birds and such. And one of them is a very cool one where you create these like bird nesting houses and you stick a lab disk in there to monitor the temperature, the humidity, but you also monitor the sound level, which is again tying back into waves and understanding how environmental sounds can make certain bird houses more or less popular if you set them up in different areas. So there's always a tie-in if you're looking for it. So don't think that just because you're physics or chemistry that this doesn't apply to you. And I think on the chemistry side, there's so much you can do with like water quality stuff, especially.
Absolutely. It all ties together. It's a really great way to just demonstrate those connections too, because these concepts tend to be more isolated because we examine them one at a time, mostly in the lab classes. And then you can see those connections firsthand a little bit more easily sometimes with fieldwork. It also shows you how messy things are. People love to simplify science. I don't know if there's any physicists or physics teachers, but my teachers would always call it happy physics land, where there is no friction and no air resistance and any of that. The same goes for biology and chemistry concepts, that everything is very purified and very sterile. And unfortunately, the real world does not work that way. So,
I mean, so that
very
leads
quickly.
me to another question I have for you, which is just the practical tips of it. Like, I know I've definitely had times where I wrote a lesson plan, for instance, one of my elementary lesson plans that I created, it's called Shade Structures. And you take one of these lab discs with its temperature probe on and its light sensor, and you have kindergartners take construction paper and they build a little shade structure or recycled materials. I can find some cool pictures for this, but then they have to compare the temperature in the sun versus the shade. And the very first time I did this activity, I tested it in my backyard here in super not humid Colorado. And then I happened to have brought this experiment with me down to Texas. So for our Texas folk who are here, I had not specified in the lesson plan, for instance, that the uh, thing that you were creating your shade with, just got the photo here, let me share my screen now, that the thing you were creating the shade with needed to be open air. And so instead, I had created this super tight, like a bunch of people had created these super tight boxes. And then we went and tested the activity, and somehow the lab discs inside the shade had were hotter than the ones out in the sun because they had kind of absorbed and turned into a little heat box. So thankfully I learned that, shortly after the lesson plan was written, when I was out with teachers in a different climate, different humidity. And so I was able to adjust the lesson plan before, say, this photo was taken, where you can see it's much more open air, wind is blowing. It got the experiment to do what I wanted to. But I mean, I've learned firsthand that sometimes field science does not go according to plan. So what suggestions or tips do you have for teachers to try and prevent, looking a
Of
little bit
course.
like an idiot in front of the people you're not trying to? How do you recommend rolling with the punches, as it were?
Yeah. Well, as you alluded to, the first thing is to manage expectations there, that things will go wrong. If you're relying on any type of equipment or, like you said, building something, what if it doesn't turn out? And then there are factors outside your control. It might be a really nice day where you see shade and sun on the day that you plan to do that lesson. It also might not. So keep in
Could be
mind that
completely clouded over.
flexibility might be necessary, but also just explain that this is the world that we live in. We cannot control everything. A lot of people want to set up their experiments, and they should, whenever possible, with as few variables as you can manage. So you want to control the temperature, you want to control the amount of light, you want to control, if you're doing field work, the time of day you're doing it or the time of the year that you're doing it. But you
In a
can't
classroom that
always.
doesn't work, you have the same class 3 times a day if
Yeah,
you're
I mean
middle or high school.
you do not have that kind of flexibility when it comes to working outside. So just be upfront with the students that this is how this might go, that things will go wrong and we can't control everything. So much like we always counsel people when we're talking about experimental design or engineering, that the process is also part of the learning. It's not necessarily getting the cleanest data back and the expected result. Maybe you compare results from your entire class, and on average, you see a difference with that lab disk temperature, for instance. And maybe if it's unexpected, you turn that into another teaching moment. Like you probably
Yes.
rack your brain, like, what is going on here? Why is this backwards? But to a scientist, it's not actually backwards. You just have to figure out what happened. I had a
Yeah, it's not that the
professor.
science broke that day.
Yes, I had a professor say once to me that many of the great scientific concepts were just the result of a scientist looking at something and was like, huh, that's weird. Because you make your best guess. You hypothesize about what you're going to see before you go out there. If you don't see anything like that, why was that? And that is just as valuable.
I
There
think
are
I
also certainly some logistical things that you got to keep in mind, right? When you're actually going, if it's even just on your campus, but especially if you're going on a field trip, make sure you got food and water and sunscreen, things like that, just to keep everybody safe. We don't want anybody having a problem. I actually did have, wasn't my student, but somebody I knew. who actually fainted on that trip to the Tempe Mountain.
Oh
Um,
no.
I'm glad that wasn't my class, but clearly they could have done a little bit more to help and prepare for that eventuality. So you never know when something like that might happen. Make sure everybody is always safe. Don't go into any situations where you could have a potential dangerous environment. So
And
that,
a general pitch out there for bring water and sunscreen. You know how many
yes.
hikes I've been on with even adult or college friends who did not bring water for themselves?
Mm-mm. Everybody thinks they don't need it, that they're somehow special, but they do.
And snacks, because especially with kids, they like, you do not want someone to have any sort of hypoglycemic reaction or whatever. I always travel with snacks. Unfortunately, my friends count on that now, so.
Mm, no. Definitely something to keep in mind. And, if this is, especially with younger kids, limit the amount of time. We
Mhm.
don't have to be outside for hours. We can go outside for just a few minutes, do what we need to do, come back in, and be back in that environment where they're probably a little bit more comfortable anyway. So,
Yeah, but I think the outside time is a good way to mentally refocus. Certainly, I do that, as an adult working, I will just go take a lap around the block when I need a break, when I need some fresh air, or my internal team knows all too well that I bring all 3 monitors that I've got set up around me out into my backyard half the time, and I'm working from outside because it's just a comfortable environment for me, but it's also a nice change of scenery from the desk I sit at the rest of the time.
absolutely. I did wonder if we would be doing the podcast from your backyard today.
There's always trash trucks and stuff running through. I never want to, have bad sound or audio quality, and it's been pretty windy, so.
Yeah, the temperature is not bad, but the wind this week has been a little high.
All right.
Good.
So let's get back on track, not just
I
talking about
suppose.
working outside, even though it's fun.
Yep.
So I guess one of the things I want to highlight is these tools that we talked about,
Mhm.
and actually show and showcase some of the phone apps that we use. So I'm
Yes.
going to share my screen here. I've got my phone here on a document camera, so you guys can see some of the apps I use. Now, in my personal life, in addition to loving hiking and rock climbing and all sorts of good things like that, I love birding. So, birds, I think, are such a fantastic way of getting students to just observe nature. Just like Evan was saying with the plants and the bugs and all of those things, birds are everywhere. So I've currently got LA birds pulled up. I just grabbed a random spot. But I can also come in here and use, this is the Merlin app, and I can tell it I want to look for birds near. Someone told me they were in Vero Beach in the chat. So let's look at the likely birds today in Vero Beach, Florida. And so I can see by different types of animals. I can even come in and use the other birding app that I have called eBird and look up like hotspots and stuff. So this is again pulling the LA area. I'll switch that out as well to Vero Beach. And you can, if you're looking for field trip ideas, you can come and find any of these little red dots here, and it'll tell you, okay, 134 species were seen at the Veterans Memorial Island Sanctuary, and there are 58 different likely species. So I can come see what species are likely there. Now, this one doesn't have pictures of them. That's one of the reasons I really like Merlin, is that it does have all these great photos for easily identifying them. But it's one of those things that you can go anywhere or explore anywhere, even remotely, and try to identify different types of birds and see what birds are similar in different places and so forth. So one of the ways I would do this if with students is just, I actually remember doing this in high school, is we took a field trip to a local pond, just a local city park that had a pond. And this was an art class, and we got to draw birds that day. But if that was in a science class, we could still draw birds, because you know what drawing does? It really makes you start looking at the little details here. So it could be, partially identifying and partially drawing, whatever bird species you see, or maybe you find a bird that you like and then you can research it. What is its diet? Well, obviously, you have an idea of its habitat based on where you've seen it, but do some more research. And so any of these birds you can like read about, you can look at different pictures, identify male versus female. So this is one of like these two apps are just constantly up on my phone.
Absolutely. Um, that reminded me of a story again that I heard in college. And take this with a grain of salt because this has been like part of a biography, but we'll see if it's actually accurate. I'm not sure. But there was a famous biologist years ago, a pillar of 20th century science called Louis Agassiz. Um, and one of his students recorded a story that for his graduate work, what he was given a fish, and Professor Agassiz said, "Take this fish and just look at it
Yes, I
and
feel like I've heard
draw
this.
it." And he was taken aback. I mean, like, what is the point of this? This is such a stupid waste of my time.
And you
But
will have students who feel that way if you ask them to draw things, but then you'll also have artsy kids like me who love it.
yes, so he tried and tried many times to reproduce this fish as accurately as he could, and he kept missing things. And every time he would bring his drawing, his professor would say, "Well, you didn't look carefully enough. What about this? This is missing. This is actually really important for how this animal lives because, this coloring keeps it safe, or this fin is this shape for some reason." And so eventually he grew to understand the point of that lesson was to accurately observe your environment and to draw inferences and then investigate some of the features you see around you. So even just drawing birds to me sounds like a fantastic lesson. And that could be interdisciplinary for any age of kid. When I was in school, I remember we went to a crane zoo in Wisconsin, where I grew up. There is a crane sanctuary, and I mean the birds, not the machines. That these very large birds, they were held there, and the ones that are native to the U.S., they would help them to migrate every year. Really cool stuff. And we did very similar things. I don't recall us actually drawing them, but we were tasked with just observing behavior, plumage, understanding the differences between these various species there on the ground. So, absolutely something you can do. I'm going to definitely have to download Merlin, I think. That
The other really cool
really
thing
cool.
with Merlin is so often if you live in super forested areas, you can't necessarily see the birds. That was an issue we both ran into when we were looking at rainforests in Australia, is you can't really see them, but you hear the birds constantly. And so Merlin has a feature that's really good in continental US where you can have it record the bird sound and it will actually use AI to give you a good idea of what bird it is. It's not 100%. It says never count on only this, verify the identification of the bird yourself. But it really helps me as someone who may not be, I've only got a couple years under my belt birding compared to some experts out there. So it sometimes tells me, okay, I'm looking at this family of birds. I'm looking at thrushes, or I'm looking at honey eaters, or I'm looking at finches, or I'm looking at like, okay, I have that it's a small bird up in a tree. I need a little more info here to try and figure out which type of bird it is. So Merlin is great for that. And
And
then you
I'm
had
not
some other
sure if
apps too you were telling me about that
I
I've got
did,
listed
yes.
here.
And they all tie together. I'm not sure if anybody has heard of the term citizen science, but not only is it really just fun for folks like yourself to go find birds that you're interested in seeing, but it is valuable information to learn the migration patterns and the habitats that those birds frequent. And the same goes for everything else.
Mhm.
So you can actually encourage your own students to take that approach, that they're actually contributing to the body of knowledge. When I moved to Colorado, I wanted to continue not doing the field work that I was in the same way, but maybe just go visit similar environments in Colorado. And I didn't really know where to start. I have a map of all the cattle tanks in Coconino National Forest, Arizona, not so much with the Rocky Mountains. So I actually emailed the Department of Game and Fish here, and they directed me to iNaturalist, which is one of the apps that I was already using. So I'd love to share that with you because I asked, where can I find these species? Is there a good place to see? And they said, hey, check this map. And so this is all really great information. I'm going to go ahead and share my phone as well.
And I will say, Evan mentioned iNaturalist to me when we were planning this, and it is so cool. I put one photo in it, and within like 2 or 3 days, I got a cool email back being like, "Hey, you've submitted a research grade submission." And I had multiple people responding to it saying, "Yep, that's that species that you told me it was," and all of this. And I'm like, "Ooh, that feels good inside. I like that."
It does. So iNaturalist is, I believe, a species recognition for about 80,000 species. There are people who browse iNaturalist, but there's also automatic ID. So if you take a picture of something or record audio, not only can it probably guess what you've seen, but there are real people who will confirm or suggest a better ID. So like if I just do a quick observation here, let's go through here. I had found a really cool spider. This is one that I saw in Queensland. Maybe Hannah saw the same one. But this picture here, it's geotagged because I knew where I was. But if you take it with a phone or an iPad, it will automatically be geotagged as well.
Depending on your phone settings, but yes.
Yes, yeah, you do have to turn that on, of course. But then I don't know arachnids. I mean, I could probably look up the common name, but let's see what it says. So it's using the picture and it's using the location. And I picked this one because I know it's only found in that environment. You can see that's its heat map of where that spider is found. And it's also quite famous. It was the very first spider to be identified by a Western scientist in Australia back in 1775. I
Oh,
think he picked this one because it looked really nice. But it's the northern jeweled spider. So I can
cool.
add that now to my list of observations. So that will now go into my total, for my account. But you can see I can look pretty much anywhere. This is around about where I live. I can search for any number of species. Maybe I want to see,
Moose.
you want to see some moose? Okay, let's look at some moose.
Everyone wants to see a moose.
So moose, technically, we're looking for Alces, but maybe I misspelled it. We got moss, but we'll go with moose. And there's probably going to be a lot of moose in this search there. But you can see these are all the places where someone has seen a moose and then put it on the app. And that looks like a moose to me. We might be able
Yeah,
to see a better
looks like a
picture if we,
back end of a moose, but yes.
yep, yep, looks like a moose. So you can see even if, someone is unsure about it, you can look and see, CC or however that's pronounced, identified it
All
initially,
these
and
other
then
people.
two other
Okay.
people confirmed it. So your students can be these people now. You could do a project either looking at what is around you, even if you don't have time or the opportunity to go outside, you can still load this up and they can identify species. They can use, guides or, some techniques that you would share, like, the moose is bigger and it has this pattern of hair on its rump that you could see there. And, this is what its antlers look like versus a deer, and you could actually do this work with them.
Well, and
And then
that sounds
they
like
could
a
be
really good
citizen scientists.
tie-in for either speaking and listening standards or writing standards to be able to describe the differences, what they're seeing, what key identifying landmarks, as it were, that we call them field markings in birding. Um,
Yeah.
but
Yeah, and the other one I wanted to show you, for some reason my keyboard isn't connecting, but I'll just tell you about it. It's called Seek. So Seek is basically iNaturalist for even younger students. Anybody can use it, but Seek is really great because, and I just loaded it up now by hand, so I could type into my search box here. Seek is really great because it doesn't need an account. So this is
okay.
another iPad and phone app. The students do not need an email address or password or anything like that. It's just local to the device. It has the same species recognition that iNaturalist does. And so this is even better for those little kids. And it has achievements. You can see I haven't made many achievements myself, but you can research different types of animals and you'll get a badge. You can do current events. So
Oh,
there's even
cool.
like monthly challenges that they'll give you, like the Solstice Challenge or the Predators with Bones Challenge. And you can try to, um, kind of enact out like real world Pokemon in this case. And you can
That's what I
see.
think about birding too.
Absolutely. I just went out in my backyard with my son, who I believe was 5 at the time when we did this. And we just looked at our garden and it was able to identify all these. I kind of knew that was a watermelon plant, but it figured it out. And then things that I did not recognize, like this damselfly. I couldn't have told you the species of that damselfly, but Seek figured it out for me. I did know what my dog was, but many of these other ones, I was pretty impressed it was able to come up with. So I would definitely um, recommend iNaturalist, Seek. You mentioned Merlin. What was the other one that you had?
eBird. And the great
eBird.
thing about all of these phone apps that we've talked about here are they are completely free. Some of them require accounts, but not all of them, like Seek doesn't. Um, All Trails is another one just for getting out for hiking. It does have a paid option, but there are free options to all of these. And then Google Photos is something that might already be built into your phone if you have an Android or a Google Pixel and use Google Photos. There's a Google Lens button that I use all the time for identifying, wild flowers and the like. So just
Yep.
definitely wanted to share those with you. And
Yeah.
then in the last couple minutes, I do also want to talk a
Another.
little bit about our
Yeah.
built-in tools that we have. Now, you've heard me mention the two different sort of lab disk products we have. We have our Explorus, which has a really nice animated screen here. Everything, this is great for especially K-5 because there's no decimal points in it. So those younger students don't have to worry about that. And it has a few sensors on it: light, distance, temperature, sound level, and then voltage as well. And then our one for higher grades is our lab disk, which you can use for every grade level as well. Either of these can be used at either grade level, but this is great for older students because it does have those decimal places in it, and it has up to 15 sensors depending on which version of this you get. But this one has like pH sensors, it has GPS. So you can take all of these field sciences out and actually track your GPS location while you're doing it. So you can, and with either of these, you can get multiple pieces of data simultaneously. So you can be tracking temperature and humidity and sound level and barometric pressure, perhaps, depending on, which one you have.
Absolutely. And this is so powerful because the phone apps that we were talking about are a lot of fun, but they are observation. And when it comes time to build the scientific skills of these students, you have to do experimentation as well. You have to make predictions, you have to test things, you have to measure things. And the Lab Disk and the Explorus are a great way to do that. The thing that I like best about these is they are wireless and they are battery powered. So you can take them outside. You don't have to tie them to a power outlet or a laptop or anything like that. They certainly do connect, but you can bring them with you wherever you're going on your experiment journey.
Yeah, so here I'm showing this is a hike I did down in Florida. And you can see I took my phone with me and I took photos of foliage or and like fauna and flora, that's what it is, that I saw along the way. So I saw an alligator and I took a picture, and I saw fungi and I saw a bridge. That's not either fungi or flora or fauna, but I'm tracking two different things here. I'm tracking both temperature and humidity, and this is how it looks on the GPS map. So I can see that as I hiked and the humidity increased because red is higher, the temperature decreased. I kind of went in a this way off to the right first and then did the big loop on the left. So it's very cool to see the inverse relationship both graphically as well as visually on a map. And I love the color coding aspect of it because for older students, you can look at this data, you can do lots of intense math side of things. And for younger students, you can just understand that blue is less and red is more, and they can see that.
Mm-hmm. It's really extremely intuitive. You see the line go down, you explain that's less. You see the line goes up, that's more.
Yeah.
Anybody, preschoolers can grasp that concept. Once you turn it visual, instead of just looking at numbers changing, it makes a huge difference. I've seen that in my own family. Just converting like the percent humidity into a line that moves up and down, instant comprehension. I hope folks have appreciated our conversation about sort of our history with field science and how we bring that into some of our products and also some of our activities at Mimeo STEM. I really want to give Hannah a shout out because she writes really great lesson plans like that shade structures experiment with the lab discs. She's got a lot of great ideas that have been published on my STEM kits for all grade levels. And it's all standards driven, state by state. So there's tons of invaluable information, whether you have a lab disc or not. So thanks for sticking with us today. I hope this was valuable to all of you. I know we've gone a little over time, but it was a lot of fun to chat about all of our favorite things to see outdoors. And hopefully this has inspired you to take your students and give them some of the same experiences themselves.
Yeah, and for anyone who needs our emails, wants to do any follow-up questions, wants more information on these products, here they are in the chat. And then join us next month. Jillian and I will be back. We're going to be talking a little bit more about these lab discs, but we are going to be focusing specifically on how to use them on a math side of things compared to on a science side. So this will be definitely talking about you know, how to use this in elementary, how to use this in middle, how to use it in high, but giving an answer to that, when am I ever going to need this question that your math teachers get bombarded with. So we hope to see you back. I also have this link in the chat, or you can use the QR code on screen, but we will be back April 16th to talk how to take this field science stuff that you're doing, take the data and apply it in a math classroom.
Love that. I always think of these as science devices, but I can't wait to see the activities and the suggestions you have on math curriculum. That's great.
I think of it as a math device.
There you go.
Okay, it's both.
Yeah, it's both. All
All
right.
right. Thanks everyone for joining. Wonderful to have you here.
Yep. See you back next month.